Hi, my name is David Christian Leadley. I'd like to show you how to run services with systemd on a DigitalOcean droplet. We're going to set up a droplet and we're going to follow a tutorial that you can find on DigitalOcean's community tutorials. If you have a snapshot of an existing droplet that you would like to work from, or if you'd like to start from a backup, it could be good for you to play around in a separate instance just to make sure that you're getting everything configured the way that you want, and then go back to your production and set it up there. This is a disposable environment and it's really quick to spin up and spin down, and it's a really effective way to practice what you're doing before you actually commit to it. So for me, I'm going to go to one-click apps, and we're going to get a head start on the things that we want to be installed on the server by grabbing this pre-built Node.js on Ubuntu 16.04. The size of the droplet for our purposes doesn't have to be very big. I'm going to do this tiny one here. New York is where I am at, so I'll choose that. I don't need private networking, and this is a disposable droplet, so I don't need that. Nothing fancy with IPv6. User data is if you want all of these steps we're about to do to be scripted and just run automatically when you're spinning up this droplet. You could paste in the shell script code that you want there, but we won't do that either. And monitoring is interesting over the long term, but again, with the disposable droplet today, we won't worry about that. I'll just go ahead and use my public key here for the box that I'm on, and this server name will be just fine for the host. Now let's take a look at the tutorial. Here they talk about how you used to need to use different tools that are made to keep things running. If you're used to PHP or another system that runs itself pretty automatically, it can be very confusing when you're running something that has its own built-in server, and that's the intended production use case. So in Node.js, for example, we used to use forever. Now systemd is very easily configurable and something that we can use just like any other system-level service. Here we see instructions for Fedora. This would be the same if you're using CentOS, and Arch if you really like pain. We'll be doing these same kinds of things in Ubuntu though. And I don't see an example there, but it's pretty easy to translate. Most commands you just change for the word apt. We'll check in on the build. Our droplet's done, so I'm going to copy the IP and we'll switch over to the terminal. SSH root at that IP. I'll say yes, the fingerprint of that host is acceptable, and now I'm in and ready to do things. So I'll do apt update. Now on a DigitalOcean droplet, because it's disposable, you pop in as a root user. If you want it to be a box that sticks around for a while, you'll want to set up individual users. It's convenient right now to have quick access to do what you need, but for the long term, if you have a box that you're using for production, you don't want to be logging in as root all the time. Here I've updated the latest lists of packages, and I'll do apt upgrade and go ahead and say yes to everything. Now a couple of other things that I like to do to make sure the box is patched against any known vulnerabilities and up to date with the latest features. In addition to updating the packages, which goes pretty fast, we'll also check on the distribution upgrades, and if we were really adventuresome or wanted to use new functionality, we could even upgrade the distribution itself, and I'll demonstrate that at the very end. One thing I like about using apt, even though most command line scripts are going to need to use apt-get, because that's a safe API that won't change and break your shell scripts. Apt is this user-friendly version that wraps that stuff, and you can see like this progress bar at the bottom. So really there's no difference between the outcome of running apt or apt-get, but what you get if you're a user staring at the screen while this happens is a much more friendly view of what's going on. And it also unifies several commands that are different if you're using the normal tools. For example, I could type apt search and try to find the name of a package, but you can't type apt-get and then search for the name of a package. You have to use apt-cache or apt-cache to be specific, and then you can search. So by unifying everything into this one place, it makes it a lot more convenient as well. So quite a number of updates. I'm going to go ahead and take the package maintainer's version because I haven't really done anything that would be settings I'd want to avoid losing. Now we're back to our shell. So I'll show these other commands. apt dist upgrade. And there we see there's nothing really there. If I wanted to do a do release upgrade, I could do that, or even add a D if I'm wanting to push into one of the development versions. And that would actually update Ubuntu itself from 16.04 to 16.10 or 17.04, 17.10, even 18.04 if that's something that would be available in the listings. For right now, I'll do a couple of maintenance commands. apt auto clean, apt auto remove. And this just makes sure I don't leave any trash on the system. So now I've got a nice, clean, up-to-date system, and I'm ready to go through this tutorial. They're showing adding a user. There are two ways to add a user. One is add user, and the other is user add. The only difference is that add user is going to be a friendlier version. Much like the difference between apt-get and apt, user add and add user are just two different use cases. User add is meant to be run as a shell command, and add user is an interactive command. So I'll just copy and paste this, and there, it's done. If I were to do add user, which is just the inverse of that command, I would then say, let's say my name, David. Here we see a new password and the full name. You can see the difference here. When I do user add, it expects some flags and a little bit of information. When I do add user, it lets me go interactively, and this is not something you would use for a shell script. Room number, work phone, home phone, other. Is this correct? No. I could do that, but I'm just going to cancel out here. So if I look at the home directory, I see the two users. One, I went ahead and started creating one, so it went as far as creating that directory under home. But here's the one that we're going to be working with for the tutorial. Here we're looking at the instructions in the tutorial. To avoid conflicts, pick a high port. Here 1503 is used. We don't really care on our server because this is just a throwaway, so we'll just follow exactly what's in here. So they're getting Node.js through the yum install, but since we did a fast forward to a pre-built image, let's just double check that we have these things. Which node? There we go. Node version 6.13.1. That should be fine. Which npm? Good, we've got everything we need. Now we want to super user as this user. So I'll paste that command. And now, who am I? I am that user. Now it shows using curl. And in my experience, a lot of systems don't come with curl automatically included. So let's check on that. Which curl? It is in this version, and that's good. So we can go ahead and just run this. If you look at the directory I'm in, it's the root user, because that's what I logged in as. I've done an su to become this other user, but when I type cd all by itself, it's going to take me to the home directory of the user that I am right now. Now let's take a look at the directory I'm in, and we can see this is where I should be. Now we're ready to run this command. Curl is going to capture whatever is at this URL. I'm thinking that's what it probably stands for, but I'd have to look that up. And at this URL, there's apparently a script there called install.sh, and I'm going to pipe the output of streaming this across the internet into the shell interpreter. This is exactly the same as if I blindly trusted every single command there, copied and pasted every single command and hit enter as the root user, or in this case, as this user. So be sure that when you run commands like this, you actually know what's going on there, because it's pretty simple for someone to insert malicious code and tell the world, try my new package. And you pull this in, you run it on your box, and you're executing the shell script of whoever is out there that you wanted to try their stuff. We'll trust this because it's a reputable source on the DigitalOcean community tutorials. Now, when I say source, this is exactly the same as what happens when my shell initially logs in. What we're going to assume here is that this exists, so let's check that. I'll copy, and I'll do it doesn't exist. So there's probably something that happened up here that would have created this, or, oh, I see. That's what we were pulling in, NVM. So it looks like that has not successfully run as we hoped it would. Let's check on why. Maybe that's an outdated link. I had to take a short break and see why this command was not working properly. I went straight to the website for NVM, and I see that there's actually a little bit missing from the command. So I'm going to go ahead and run this current one from the website. Maybe leave a comment at the bottom of this tutorial to update this so that others don't get stuck. When I run this command, curl is going to pull and stream the output of this URL into bash. There we see the output that's confirming that this much data was pulled, and here we have run the commands, and now we should have the directory that we're looking for, which is NVM. And what we want to do to execute this NVM script, which basically is a shell addition that lets you stay current with multiple versions of Node. We're going to continue on down these steps and do source. You could use this same source command on your RC file for bash or Z shell, or you could use a dot, but this is just a way of telling the shell, please add the contents of this file to the current running environment. And silence is good. It means that it worked. So now we're going to get a very specific version of Node. Even though we have Node version 6.13.1, to make sure that the tutorial goes exactly as it's described here, we'll go ahead and follow what they say, and we'll get version 0.10. Now it's not replacing 6.13.1, it's actually getting its own directory to keep it separate from the system-wide installation of Node. And we're going to set that to be the default, and that just means when I type node or npm that we're going to reach for this separate version rather than the default that was there, which was installed at the system level. Now they're showing how to find out where that landed, and that should be pretty much the same here. 1048, and this is 1022. So there's been a little bit of change over time, but because this number has stayed the same, it should be exactly compatible with what's happening here. Now here's another command we have to make sure we have git on this machine. There we go, we've got it, so we can run this command. So this would only apply if we were actually deploying something that we were storing in a Git repository. What we're going to do now is type an example script just to test. I realized when I checked earlier here that the reason that we had Node.js installed native and then an example of NVM was because we wanted to demonstrate two different approaches. So for example, if you are running on the system as a server, you'd probably go for this one, and user specific was the reason that we saw two examples in that area. And this is also an example of what you would do if you were deploying as a server, and what we're going to do instead of pulling from a proper repository is just type a file really quick on our own here. So I'll copy this, and I can tell this little bit here when you're doing Markdown and you do 3 ticks, you can specify the syntax that you want highlighted. So I think that's just a leftover. But what you really want is this little piece right here. And I'm going to copy that, and we're going to just create a JavaScript file on this server. And what I can do is touch a file called myserver.js and then cat into that myserver. Whatever I paste now is going to be streamed into that file, and then Control-D will terminate that stream, and now that should be inside of my server. So we should be able to run that with Node, and we're going to return to the root user now by exiting out, because when you su into another profile, it spawns a new login shell. So now exiting from that other user, and we'll see that we are in the root. So let's go to cd home serve, and we'll see there's the file that we want to run right there. Now we're going to configure nginx. This is the configuration that we're going to place in the server block. We can go into further details in a different video, but for right now let's just double check, do we have nginx on here? We do not. So I'll do apt install yes to everything nginx. Now what we should be able to do is edit the nginx config file with our favorite editor. However, since Emacs is not installed, I'm also going to do apt install yes to everything Emacs, and I'll do a special flavor of Emacs called nginx, meaning that there will not be anything installed for window management. We're just going to use it only on the terminal. Now I can do what I want, which is to Emacs and use dired, the directory editor. So if we go to etc nginx, we can see the configuration files that we'll be modifying. Now because it said that we want to place this in the server block, I think it's okay to go ahead and use the default. nginx.config. Here's the HTTP block, and what we see here is that it's including all of the files with the .conf inside of the conf.d. So I'll go over here and I will look at what's in there. There's nothing in there. And it's going to include all of the config files inside of sites enabled. So I will go into sites enabled, and there we see there's the default configuration for the default site. In here we see there's the server block, and that is what they said in the tutorial, place this in your server block. So what I want to do is check out what's there already. I see that we're listening on port 80, and here's something that's doing the IPv6. Again, here is the SSL version of that and IPv6. And let's find out what we're talking about here. The location for the root, and that is here. So what I can do is come in and paste. Sorry, I did not catch the right thing here. Let me capture this, copy, now paste. And that's quite a mess. looks much better. So we've got two blocks now. This one was the original. This one is the one that we want. I'm going to select everything of the original and kill it. So now all we have is that localhost will be passed to port 15301, and everything's going to be forwarded. I'll save that. Now I need to enable nginx and restart it. No, I just pasted the wrong thing there. My keyboard doesn't seem to want to copy well. Okay, I have enabled, and now system control restart nginx. That means it should catch this when we run it, but we're not running it yet. Let's try running it manually before we continue with this tutorial. So there's my file, myserver.js. I'm going to just tell it, Node, I want you to run myserver.js. Now it's running, and we should be able to see that if we go to this, we see hello world. That means that port 80 went well. Let's see what's happening if we look at the port that was set here. 15301. So it's just hanging and hanging because it can't really find anything there. However, what we told it to say was hello world, and internally it's listening on that port, but not externally. So it's never going to load on the port that we've set to serve internally because we've rerouted port 80. That's where we see it. And that port 80 is then, through nginx, reverse proxied over to that other internal port that we've told Node to listen to. Now the problem is I can't walk away from this. I can't just exit and close my terminal and walk away. So if I hit Control-C to break and we come back over here, uh-oh, it's broken. So how do I keep that running? There's a couple of things that I could do. One of them is to run an instance of screen, which is something that runs a shell that you can step in and out of without having to keep the SSH connection. So let's just type screen. And here we see a message that tells us what's going on, and I'll hit space, and now it feels like nothing's really happened. If I type screen list, you can see there is a screen on this machine here. We can see that it was started up, and this is UTC, of course, I'm not up that late. And it is attached right now, and I'm in it. I will say exit. And now we see the previous place that I was. I'm going to type date and then screen. Now I'm back inside of the screen, but this is a fresh one, and that's not what I want. I want this screen to keep running. So here I'm going to say, who am I? I'm root. You stay the same user as you were when you start in screen, but when I exit, remember I'm in screen. When I exit, screen dies. That is not what I want to do. What I want to do is detach. Now, because detaching is a little bit confusing, let's start a service inside of there that you can really see. Here's an example, one more time before we do that, of starting something and stopping it. Here's starting Emacs. Okay, I'm in Emacs, I'm doing Emacs stuff, I'm done. I'm going to Control-X, Control-C, and I've quit Emacs. Now, we're going to go into screen, and we're going to start it there. Okay, now we're in screen, pressing space, and I'm going to run Emacs. And here we are. I'm going to find a file. This is a test.txt. I am running in screen. Okay, I'll save that file. Now, this is where it's tricky. The default key binding to issue a command to screen is Control-A, which is frustrating because in Emacs that would take me to the beginning of the line right now. But screen is running, so it caught that sequence, and when I tapped Control-A just now, it's listening. There's no rush. It'll wait until the next time I press a key. And the key I'm going to press is the letter D as in Delta. Now, I just detached from that screen. In fact, you can see right here the message detached from that screen. I'll clear so that it's a little less confusing. What we have now is a running screen. I'll prove that by exiting out of this droplet. I'm back on my local host. Now I'm going to SSH back into that server. Here we see, okay, I'm back in the server. And now, can I list and see that there is a screen running? There is. Okay. Now, if I do screen uppercase reattach, it's going to just be a safe way to bump my way back into that screen. You're going to see that Emacs has been running there this whole time, even though I left and came back. And there it is. This is a running process that is not married to the fact that I am logged into this system. One more time, Control-A to issue a command to screen and tap D as in Delta. And I'm out of screen, but I'm still on the droplet. Now to get out of the droplet, exit, I can go home, do whatever I want. Now, I'll show some more tricks to keep everything flowing smoothly, especially if you're an Emacs user, because that Control-A thing is really frustrating. So let's get back into the droplet. We're in the droplet. Now, let's get back into screen, reattach. So I can't do what I want to do in Emacs anymore. What I will do is find a .screenrc file. It doesn't exist yet. In fact, let me cancel and show you that it doesn't exist. There is no screenrc file. However, I'm going to find .screenrc, and inside of that file, when it exists, Screen will wake up and it'll see that file and it'll do what that file says to do. I'm going to tell it escape, tick, tick. Tick is the escape character for this file. So I'm going to save that, and I'm going to actually quit out of Emacs. I'm still in screen. I'm going to quit out of screen. It's terminated. Just to clean up, now I'm just me logged in at the root account of the droplet. I'll type screen list just to make sure I understand how many screens are open, because you can have several actually, and give them different names and have different stuff running in them. But right now, nothing's open in screen. I'll type screen. Okay, now I'm inside of it. And that means I should have, after I space to just run here, I should have that tick be yes. When I did tick D as in Delta, instead of Control-A, that tick, not the tilde, the same key, but not holding Shift to create the tilde symbol, but just tapping tick. It'll let me type that tick symbol right now because I'm not in screen. But when I'm in screen, it's a magic character. Tapping it means I'm telling screen, hey, listen up, I'm about to issue a command to you. Not meant to be typed out on the screen here like I can do outside of screen. But when I resume and I'm inside of screen, it is tick D and I'm exiting out. Now, it's really confusing to see visually here unless I have something running constantly. So again, I'll reattach to this screen. I'll run something, which will be this text here. Now I'll do backtick D. I'm out. I'll list all of the screens running. I see, okay, here's a running screen. Let's go into that screen. Let's find out what's running inside of that. I'll reattach, and boom, this is what's running inside of that screen. I know the word screen in English means like the physical display that you're looking at, but in this particular case, what we're talking about is a binary executable Linux program called screen, and that is what we're saying when we say we're inside screen here. Now, I'll do Control A. It used to be the default combination that would tell screen, hey, I'm about to issue a command, but we've changed that. So now Control A in this particular configuration that we've set up is doing what it should do for Emacs, which is go to the beginning of the line. Control E goes to the end, Control A goes to the back. Now, if you're used to doing this all day long, you can tell why it's pretty important to change the default behavior, because if you're in Emacs and you're typing along, this is my next sentence, and you want to go to the beginning of that, and you press Control A because that's what your muscle memory tells you to do, and nothing happens because, well, nothing visibly happens, because Control A is being captured by the screen program, and it's waiting for the next thing that you type. That's why it's important to have that changed to be something unobtrusive, like this backtick, and D to detach, and now everything is as it should be. So I'll reattach inside. What if I actually want to type a backtick? Well, then I'm going to do backtick. Now screen is listening and it's thinking, okay, what's my instruction? I'm going to tap the same exact key a second time. Now it's going to pass that through and it'll actually echo that character backtick onto the screen, onto the editor that I'm working in. The next time I press it, it's still listening for its instructions. So I could tap D and detach, but if I want to enter another copy of this character inside my editor, just remember that that second time I press it, now it is echoing. I can press it a third time, well, now a fifth time, and it's listening on screen again. It's thinking, what's my instruction? I want to tap D. I've detached. I can exit and go home. If that doesn't make sense, let me know and I can do a little more detailed video, but I think I've kind of done overkill on that already. So right now I'm on my Mac. I'm going to SSH into that server. I'm in the server. I can look at the screens that are running. I see, okay, here's one running. I'll attach to it, or an upper reattach, and there we are. That's what we left running this whole time after we left. So I'll save and exit out of Emacs, because what I really want to do here is start screen, which I've just killed, and have it be running this listening node program on that port. So let's do that. This is clean. I'll actually exit out. Okay, I'm on my Mac. Now we're going to SSH into the droplet. We're in the droplet. Now I want to run the node script, but I want it to stay running inside of screen. We'll check. Are there any screens running? No, there are not. So we're about to start the special screen that's going to be the server screen. Boom, here we are. Now I'm going to press space. Usually I get rid of this startup message too, but it's kind of useful to tell once you've started it for this video. Press space to get out of that message, and here we can run Control R node. Oh, you know what? I'm not doing what I want it to do. There, node space. That found a good match. This is the command we typed before. That's what I was doing. Control R to reverse search for this command because I didn't remember it. I wanted to find it from my history of the things that I've typed. Now, this command is going to run. Remember, we're inside of screen right now. Okay, there's a problem. Let's see what that is. Cannot find module. Root. Oh, I know what it is. I tried running this command, but I tried running it from a different location. There is no such file in this location. So, of course, I need to change directories to home. I'm hitting tab again, and again, and it's giving me this autocomplete because I forgot what's in there. So now I start typing, I hit tab again to autocomplete. Now I'm in the correct directory. I can see all the files there. I can see the file myserver.js. Control R node space, because that was the first few characters of the command I know I'm looking for. Control E. I'm at the end of this line ready to hit enter. I hit enter and nothing happens, which is great because this is exactly what happens when you start Node and you're serving. Now, an interesting thing will happen here. When I go back to the browser and I hit port 80, there's Hello World, back over to the running version. If I had logging turned on, this would be echoing out right here. So you'd see all kinds of log entries and stuff. It's totally the wrong place for logs to go. They should be saved to a file. But it's one step forward as you're building out your whole system. So I want this to stay running. So I'm going to tap my new escape key, backtick, D as in Delta, and I've detached from that. I'm going to exit and clear. Okay, now I'm on my Mac. I'm not on the droplet. However, what I've done is detach from a running instance of screen. That means that somewhere out there, that process is still going. And when I hit enter, there we go. I've refreshed and Shift Command R. Okay, so this is just going to keep serving. However, there's a better way, and that's the whole point of following this tutorial. Because if we use the systemd approach, then this will allow us to have it start when we reboot. It'll have it be right up next to a first-class citizen like nginx itself when we want to use systemd to start and stop that as a service. And it will do things like logging for us. So this is the right place for us to really have a solid, reliable, up and running service. And that's what we'll do instead of screen. Let's get back into the server. Here we are as root, and we're going to see, oh look, here's a system restart required. Now if I do that, reboot, okay, we've just shut down our connection and everything, and we've forgotten, oh yeah, we had this screen running with an active process. It's probably rebooted by now. It's a fast box. So yeah, we're back in, and we could look for grep node. Aha, no node is running. We can look at a list of all screens. Oh no, no screens are running. So the reboot has killed this delicate process that we balanced carefully inside of a detached screen, and that's no good. That's the whole point of doing what we're about to do here. So systemd is going to base all of its actions on the files that are found inside of etc systemd, and then here's a system, and we're going to create our own file, a .service file called node-sample. I'll go ahead and copy that path. I got too much. Just to the end of the E, Command copy. I'll come over here, and that's a file, so I will touch and then paste that long name, make sure it looks right, and hit enter. Now that file exists. So we've seen earlier that there are two different ways that you can install Node, at the system level or using the Node version manager. Whichever one it is, though, you want to make sure that it's the one reported by this user. So I'm going to copy that user, come back over here, and do the su username. And here we're seeing an error with NVM. Here's why. Look at the directory that I'm in. I'm in the root directory. Let me exit. Now I'm root again, and I'm going to change to the directory of the user I'm about to su into. srv. There we go. So here's the directory I'm in. Now, as I su that user, all of the startup scripts that run whenever a login shell is initiated are going to run in this directory rather than outside of it in the old one that I was in. And there we see no error. This is because in this directory we have the NVM folder, we have the profile that imports it. All of these files are unique to that user, so unfortunately it isn't going to run unless you su in from this point. But since I've done that, I can now do which node, and I see here that we're not using the system node, we're actually finding this version of node. So that's the one that is being requested in the tutorial here. When they say which node, and that's what we've run, we're going to see the path that we want to use down below here. Now, I'm the user that I want to be, and I'm ready to edit this file. Just copy the path here. Remember, we did touch on that earlier, so it does exist, but assuming we haven't been doing anything with that file in the past ever, it should be just an empty file waiting for us to do something. So now I'm going to do Emacs to open that file as root, and then I'll go ahead and just grab this so that once I'm in there, I'm ready to paste it. Okay, I'm ready to hit return and open Emacs on that file. There we go. Now I'll just go ahead and do a comment and save that for later. And then we can safely paste all of this. And now we're ready to edit so that it's accurate. So I'll get lined up at the first character I want, and Control K will kill everything to the end of the line. Now over here where it says node binary, I want to change this, and Control Y will yank. So I'm going to execute node, and I'm going to pass it whatever file name we gave it here. So let's split the screen and take a look. Inside of this directory, well, that looks really ugly. Let's just make it the one thing on here. We have myserver.js. So that's what we want to put here, myserver.js. And then these directives give instructions to systemd. You always want to restart. So if it goes down, it'll catch that, it'll bring it back up again. Standard output is going to go to system log. You remember earlier we saw that when we ran our node script from the command line, nothing came out. If something was coming out that we could see visibly, this directive would capture that and it would direct it to the system log. Same thing for error. The error log and the standard output can be two different things if you want, but they're both going to the same place. The identifier that you're going to see in the system log, so that you can tell that it's logging from this instead of some other process that's managed by systemd, is going to be node-sample. That could be anything that you want it to be, but it's going to match so that when you find that log entry, it's easy to associate it with the service definition in systemd, and of course the user, the group, and the directory where you can find this file, and hopefully good naming practices in the file too, so you can tell that all these things are related. Here's that same naming convention for the user that we've created. Remember, every user has a group that's exactly the same as their name. And then the environment for node is production, and wanted by multi-user target. So making sure that it's at least one blank line at the end. I'm going to remove that comment that I had earlier, and Control X, Control S will save it. Control X, Control C will get us back out again. Now that we have a definition for all of this, we can go ahead and use systemd with system control, enable, and then the name that we've defined. We've created a symlink now from this here to the file that we've defined. Now we're going to tell it to start. And it looks good to go. So let's check the status. There we go. We can check on the memory, how many tasks are running, what's been loaded, lots of information. The main thing that we're worried about right now is, will this keep running, and is it running right now? Let's come back over and check. I just refreshed, and indeed it is. So instead of what we did earlier, where you've got screen running detached and hoping that that server stays up, we've now wired it deeper down into the system itself. In the same way that you can check the status of the thing that we just built, you can check on other things. For example, here's nginx, and you can see what I mean by saying that our program is now a first-class citizen. Just like these major important services that are running, we stepped into that same room and said, hey, I want to play here too, not just balancing our product delicately inside of a sort of hacked together runner, but actually putting roots down into the system so that it gets all of the benefits of being a part of that ecosystem. And remember, we've named it the same for the logs. It'll have that tag there, so let's check the logs and see what's in there. And here we go. Started this service here. So if we want to system control restart our app, we can do that. And I'm going to clear really quick just so that it's nice and clean to see. This is a restart. And of course you can just stop it. And if it dies or is killed, it's going to automatically restart itself. So let's test that. We've got the status. Here's the process ID. So I'm going to copy that. I have to hit Q to get out of the end of that. And then I'll say kill that process. Now, did we actually kill it? Well, yes, but did it stay dead? Nope, it's back. And we can see it's been given a new process ID because it did die, but systemd is bringing it back again because we told it to. So if your application uses WebSockets, you have to add this to the nginx configuration. And the reason for that is, remember that we're doing a reverse proxy. Our app is not running on port 80. So when we access port 80, nginx needs to know how to handle that on the back end internally. Internally, we have a port that we have set that is where this app is being served. However, nginx needs to know all of the pieces of the request that should be passed over to that app. So if you're using WebSockets, make sure that you add this into your nginx configuration as well. Let me show you something I promised earlier, and that is we're going to do release upgrade to a developer release, and we'll see what we have available here. So another port will be opened, 1022. Okay, I'm going to say no, I don't want to continue, so I can open that port myself. And here, press X to destroy, and we'll see UFW status, the status of our firewall. Okay, so UFW allow 1022 rule added. UFW restart. Is it reload? Reloaded. UFW status. So you see I've added port 1022, which is the one that we were just told that we would need, and here's why. We are connecting to a server that's going to update itself. So an additional way for us to get in is being created, just in case this SSH connection breaks. If it breaks, we could be just locked out permanently. So we now have 2 points of entry, the one we're currently on and port 1022, just in case. So now I'll say yes, let's continue. There's the same message, but IP tables, which is a lot harder to use. UFW did the same thing. It's a uncomplicated firewall. Hitting enter, and it's going to go out and figure out what updates are available for us. Not just packages on the system, but an actual update to the version of Ubuntu that is being run here. So here I can see, if I say yes, all of the sources of packages that we could pull will be changed from the current release to the Bionic release. That's an 18 branch. So I'll say yes. And surprisingly, there is a way to get back from this, but you have to get in there and edit those source files. I've done it on my personal laptop where I had completely broken it from years ago, and I had to go in and rewrite everything. Let's see, do you want to start the upgrade? Yes. So, this is how you would upgrade from, say, version 16.10 to version 17.4. This is how you'd upgrade from 17.10 to 18.04. Anytime that you want to do an upgrade, you can choose. If you add the -D as in Delta, that will add in the option to upgrade to the latest developer version. And if you don't want to live on the edge like that, you can leave off the -D, and then it will only allow you to do this when there's a long-term support release available. And the whole point of doing this is not just to show you how you can do this. It's a good thing to know. But what we're curious about right now is, even with something as major as upgrading the version of Ubuntu itself, the operating system running this server, will our service that we've set up under systemd still be running after that upgrade, after completely updating everything and after rebooting the server? Will it still be running? Because that's what we're hoping will be the case. If that's what's happening, you can put a lot of trust in this approach to using that to keep your service running no matter what's happening. I'm going to install the package maintainer's version of sshd-config. I haven't changed it, so I'll go ahead and take the latest. It's probably identical, but just to keep everything fresh, the times that I would think about not accepting the package maintainer's new version is times like right now. We have edited our sites available default. So, install the package maintainer's version. That would undo all the work that we've done. Not all of it, but the part that makes it work. Keep your currently installed version. That's N. And that's what I probably want. Show the differences if we're not sure and we need to check it out. Or drop into a shell if we need to work on it. So I'm going to say N. This should keep the edited file. And really, we were kind of taking a shortcut by doing that. What we should have done, for exactly this reason, is to have created our own host in a separate file so that any overwriting that may have automatically occurred on that default file would not have taken it down. We're going to remove obsolete packages, no problem. Restart is required, yes. Of course, that kicks us out. We no longer need that backup port. Everything's complete, and as soon as this server reboots, we should be able to just get right back in on port 22, which is the default for SSH. We're back in. We're up to date, and now we'll do uname all and lsb release all. Here we see we have upgraded to 18.04, the Bionic Beaver version of Ubuntu. Let's check, did our service stay in the setting we wanted? There it is. That service stayed up. It survived a system level operating system upgrade and a reboot, and it's still ticking. So using systemd to manage your services is the way to go. Alright, thanks for checking this out. Please let me know if you have any questions.